Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is on section 4.4, the Pythagorean Theorem. By the end of the lesson, you should be able to use the Pythagorean Theorem and the distance formula to find the lengths of sides of a triangle. Before we jump right in, there's some really important vocabulary that you need to know in order to use the Pythagorean Theorem correctly. So all of this is about right triangles today, and that's when we're going to use this, as we use all of this with right triangles. This is a special scenario. So the legs of a right triangle are the sides that form the right angle. So that's two of the sides. The other side is called the hypotenuse, and that is the side opposite the right angle. So we're going to draw a picture to go with this, of course. So draw yourself a nice right triangle. Put a right angle in there. All right. So there's our right triangle. The legs are the sides that form the right angle. So this is a leg, and this is a leg. So yeah, they're forming the right angle. The side opposite the right angle is the hypotenuse. And we're going to use the Pythagorean theorem, which is c squared equals a squared plus b squared. And you're going to know this is always c. The hypotenuse is always c, and that's really important to remember. The distance formula, you also learned this in Algebra 1, is a formula that calculates the distance between 2 points in the coordinate plane. And I'll give that formula to you in just a little bit. We're going to do lots of finding length today in triangles and the coordinate plane. But this is really important that you understand this. The two legs form the right angle, and the hypotenuse is across from the right angle. So here's the Pythagorean theorem, which I know you've heard before. C squared equals a squared plus b squared. It's really, really important that you understand that this is the hypotenuse squared. This is leg squared plus leg squared. So that helps you. Hypotenuse squared equals leg squared plus leg squared. Please use that, because you need to know that c is the hypotenuse. The square of the length of the hypotenuse. So look how they've labeled this. Little c is the longest side, the hypotenuse. The hypotenuse is always the longest side. So we're going to practice. Find the length of the hypotenuse. Okay, well, it's a right triangle. These are all lengths. So I know that c squared equals a squared plus b squared. I'm going to do it over here to start. C squared equals a squared plus b squared. All right, and the one across from the right angle is c. I like to circle c so that I always remember which one it is. It's really important. So c is x. A, well, it doesn't matter which one you choose as a or b, because it's going to be the same. So I will just do 5 squared plus 12 squared. All right, so now if you remember your order of operations, you have to do exponents first. I can't do anything with that. But I know that 5 squared is 25, and that 12 squared is 144. Now I'm going to combine my like terms. 25 plus 144 is 169. Now we have to get rid of this squared. I want just x, not x squared. So to get rid of the squared, you have to take the square root. The square and the square root cancel each other out, which is what we want. And we're left with x equals, now you have to take the square root of 169. Well, you can put that in your calculator, or maybe you know that it's 13. So the length of the hypotenuse is 13. Alright, so I wanted to kind of show you over here first, but we can, oops, they want to substitute in the real numbers now. So this was 5, 12, 25, 144, 169, 13. Exactly what we just did over there. Okay, let's look at this one. First step is to identify your hypotenuse. So identify your C value. Here it is, the one across from the right angle. There's my C value. So I know C squared equals A squared plus B squared. I plug in, C is 14. A, you can use 7 or X, it doesn't really matter, and B is 7. Alright, the first step is exponents first. So 14 squared is 196. You can put that in your calculator if you need to. And 7 squared is 49. Alright, now think about when you solve an equation. The next thing you're going to do is to subtract 49 from both sides. We're left over here with the 147 equals x squared. Same thing, I got to get x all by itself. I don't want that squared anymore, so I take the square root, and I take the square root, and the square root of 147, oh, it's a decimal, it's okay, so I'm going to put approximately around to the nearest tenth, 12.1. Alright, so if you want to do it over here, it's the exact same thing. I just like to write it out. Subtract 49 from both sides. Take the square root. And you're left with 12.1. So obviously the most important thing is that you get your values right from the beginning. You make sure that you found the correct C value. All right, you get to do this now. And I always like to start by writing C squared equals A squared plus B squared. Now I want you to fill in what each of these are. Substitute in and solve. So substitute and solve. I'm going to write this here for each of them. So I would go through and circle your hypotenuse, circle which one's always across from the right angle. So you need to substitute, and then you need to solve. Go ahead and do that, and we'll check that later. All right, the distance formula. This is another way of finding length, but this time it's if we're in the coordinate plane, the XY plane. And we've learned this before. I think you found it in Algebra 1. So in order to find the distance between 2 points, what you do is you subtract the x coordinates and square them, plus then you subtract the y coordinates and square them, and then you take the square root. Right, see, it's kind of like, this is kind of like your a. It's like a squared plus, this is your b. You have to subtract the y's to find b squared. And then you take the square root. All right, so that's kind of, this is exactly the same as the Pythagorean theorem, but now we have to find a and find b by subtracting the x's and subtracting the y's. But notice, that's how we get, if we want to find this distance between a and b, this is our a squared plus b squared equals c squared. So we'll practice. If you're confused, it's okay. We're going to practice. So use the distance formula. Right, find the length from here to here. All right, let's write out the distance formula first. It's kind of a long one. Subtract the x's and square them. Subtract the y's and square them. All right, we got to make sure we know which one is x and which one is y. So hopefully you remember that x always comes first. So here's x, there's y. So that's d. For e, x is 3, and y is -2. So now we need to plug all this in. Let's plug in our x values. All right, so x2 is 3 minus 1. 3 minus 1. Squared, right? I'm just plugging into this formula. Then my y's, -2 minus 2. Now we have to simplify this. All right, and you can use your calculator if you need to. But I know that 3 minus 1 is 2. Don't forget your square root. And -2 minus 2 is -4. Make sure you keep that in parentheses. Otherwise, when you put it in your calculator, it's going to calculate wrong. Okay. Now 2 squared is 4. And -4 squared, if you make sure you put these parentheses in, otherwise you're going to get it wrong. -4 squared is +16. Both of these numbers should end up positive. If they don't, then you did something wrong. And this 4 plus 16 is 20. And the square root of 20 is approximately 4.47. When I put that in my calculator. Can example 3 be done using the Pythagorean theorem rather than the distance formula? Yes. Look at this. Let's turn this into a right triangle. All right, now let's find the leg. So this leg is 2. And this leg is 1, 2, 3, 4. These numbers should look familiar, 2 and 4. So now, and this is our c. So we can do c squared equals 2 squared plus 4 squared. All right, simplify this. 4 plus 16. These numbers should look familiar to you. We just did 4 plus 16 equals 20. Take the square root. C equals 4, or approximately 4.47. Just like what we did up here. So the distance formula and the Pythagorean theorem are exactly the same. All right, so now I want you to try this. Give it your best shot. Let's write out the distance formula. So we're trying to find DE. You need to substitute and solve. This is M cubed, signing out.